We're going to continue our discussions and lesson on arithmetic sequences today that we started yesterday. And we'll start off by looking at just a couple of examples to kind of refresh what we did yesterday. We looked at, this might even have been, somebody last hour said this may have been one of the ones you did. I didn't do that on purpose, but we have a sequence. And yesterday we put the terms of the sequence where?
The Y.
The Y column, so 5, 9, 13, 17. And then X was 1, 2, 3, and 4 because those are the term numbers. And then we wrote our function rule. So f of x equals, anybody?
F of x times.
Well, what's the difference between each term?
Times 2 plus 1.
So it's got to be there's got to be a 4 in there somewhere since there's 4 between each one. So 4x
4x plus 1.
plus 1. And we would fill out, and yesterday, we're not going to do that right now, but we would have filled out the rest of the table 4 times 1 plus 1, 4 times 2 plus 1, and on down and filled that out and shown that it works for each of the terms of our sequence. Then we want to find the 33rd term. So where does 33 go? It goes in for the x. So 4 times 33 plus 1. And that would be, you guys are going to need your calculators out.
114.
No, you're gonna need your calculators out for some of the stuff we're doing here in a little bit. So go ahead and
133.
133. So x is 33, y is 133. Okay. All right. Well, one thing we didn't look at yesterday was descending terms. And descending terms are descending sequences, actually. Descending sequences. So in this case, if we were going to build our function table, what goes in for the y?
8 by 2, negative 1.
-1, and then the x is still 1, 2, 3, 4.
And subtract 3.
And since it's going down by 3,
So it'd be negative 3x divided by
times negative 3x. We're going to multiply by a negative 3. Negative 3x. So negative 3 times 1 is negative 3. And then what do I do to get to 8?
Plus 11.
Plus 11. See if it works. So negative 3 times 1 plus 11 is 8. We already know that. Negative 3 times 2 is negative 6 plus 11 is 5.
It works.
It works, okay? Negative 3 times 3 plus 11 is 2. Negative 3 times 4 plus 11 is negative 1. Okay, so this whole system that we have in place now does work for descending sequences as well. Yes?
Is it possible to find a sequence that works with the first two but not the other two?
I have never seen such a thing. I don't know how, I hesitate to say never, because then somebody will show me a way to do it, but I don't think so, and certainly not for the stuff that we're going to be doing. All right. As long as there is a common difference, it goes down by the same amount every time, you're going to be safe. This whole process works, and you guys have got to know how to do this. You've got to know how to take a sequence and write a specific function rule to make that sequence work. That's part of what we're doing in this chapter later on, and with some of the things we're going to do, we're going to be graphing these things. So you have got to be able to do this. But as far as some of the things that we've done, where all I want you to do is find, like, you know, if I wanted you to find the 50th term, you guys would be able to write the function rule and figure out the function rule and then find the 50th term, right?
Yeah.
Not too much trouble. But there is a way, a formula that we can use that will work for any arithmetic sequence that makes finding that nth term or that 50th term or whatever term I guess, a little easier, because you don't have to come up with a specific function rule. The formula will work for any sequence. So that's what we're gonna look at today. We have here the parts of an arithmetic sequence, and you need to know each of the parts of the sequence so that later, in just a second when I show you the formula makes sense. Because if you don't understand the parts of the sequence, then you won't know where to plug numbers in at, or where to substitute numbers into the formula. So the numbers that make up the sequence are called terms. So 2 is a term, 4 is a term, 6 is a term, 8 is a term, and so on. Okay? And we might look for any given term. I want to know what the number is for the 100th term, or for the 50th term, or whatever. Okay? The difference between the terms is called the common difference. It is described with the variable d. So for all the sequences, d will mean the difference from one term to the next. In this case, for this sequence, what is the difference?
Plus 2.
It's a positive 2. So on this one, d would equal 2. Okay? The first term is described by the variable a. So a will always be the very first term in the sequence. In this case, a is 2 because it's the very first term of the sequence. And then an unknown term is described by the variable n, some term out in the future. If I want to know the 50th term, we'd call n50, because that's the term that I'm looking for, okay? So sometimes you hear people talk about the nth term. So all of those definitions come into play when we get to the formula, which we'll look at right now. The sequence is 11, 17, 23, 29. And we want to find the 57th term. Now here's the formula. You need to write this down. We're going to write it down on every slide that we go through today, so you get a lot of repetition on it. But you need to have this in your notes. And this is not in the book, by the way. They don't give you this formula. We're going to put the formula like this. T equals A plus n minus 1 times D. Now, t is the value of the term that we're looking for. So 57th term, what number in this sequence is going to be the 57th term? That's what we're looking for, okay? So the first thing I want you to do is to identify each of the variables. What is a?
11.
A is 11. What is n?
57.
N is 57. N is that term that we're looking for. And what is d?
6.
What do you do to get
3.
from one term to the next? 11 plus 6 is 17. 17 plus 6 is 23. So D is 6. Now here's how the formula works. T equals, just substitution is all we're doing now. A is 11. So it's 11 plus N is 57 minus 1 times 6, which is D. And once you get the number substituted in, then it is an order of operations problem. Make sure that you observe order of operations, otherwise you get the wrong answer. So what comes first?
Parentheses.
Parentheses. We have to do the 57 minus 1 first. 11 plus 56 times 6. So what comes next?
Multiplication.
Multiplication comes next. T equals 11 plus
336.
336. So T equals 347. All right, so the 57th term would be 347. What is that in terms of the x and the y values that we were looking at the other day?
Term equal x.
Where would 57 go?
Oh, the x
In the x column, where would 347 go?
column.
In the y column. So x is 57, y is 347. We could write it as an ordered pair even, 52. It's not what I was trying to do. 57, 347 would be our ordered pair, right? Okay. Well, let's look at some more examples. We're gonna do about 5 or 6 of these together, 4 or 5 of them, and then I'll get you onto your homework. What is the formula?
T equals A plus N minus 1 D times D.
And then A is
17.
N?
87.
and D,
12? What?
yeah, 12.
Okay.
I hear a phone going off. That's not fine.
T equals
17 plus 87 minus 1 times 12.
times 12. All right. So T equals 17 plus 86 times 12. You're gonna have to help me with the math on these. T equals 17 plus
1032.
1032, so T equals 1049. And if we wrote it as an ordered pair, what would it look like?
87, 1049.
Okay, X and Y value. All right. Now what about descending sequences? You think our formula is still gonna work?
Yeah.
I would hope so. What's the formula?
T equals A plus N minus 1 times D.
All right, A is
51,
N
193,
and D,
negative
-2. I mean, -12. Wait, no, I'm confused.
-8. What do I do to get from 51 to 43? Subtract 8, so it's -8. All right, so T equals 51 plus 193 minus 1 times
Negative
times
I mean,
-8. And don't forget to, this is why I want you to put parentheses around the D term here, because otherwise some of you will think it looks like -8 when you're doing the operation, you'll get confused. So T equals 51 plus 192 times -8. T equals 51 plus
200. Oh, wait, no,
Negative
1,536. Yeah.
1,000, how much?
536.
536. Okay, so T equals negative
1,485.
negative 1,485. Good. All right. It's going to work with really big numbers in really big sequences. So T equals what?
T
A
equals
plus
A plus N minus 1 times D.
Good. All right.
A is 145.
A equals 145.
And N is 452. And D is 92.
92. T equals
T equals 145.
145 times N. 452 minus 1 times 97. 92.
okay. So T equals 145 plus 451 times 92.
41,492.
That's a big number.
41,600.
637.
All right. Now, last question. Last example. Is it going to work, do you suppose, with decimals in descending order?
Yes.
Of course it is.
No, it doesn't.
You're hoping it doesn't, right? All right. T equals A plus.
N minus 1 times D.
All right. So A is
4.2.
N
50.
is 50 and D
Is 1.
No, negative 0.5.
Negative 0.5. All right. T equals
4.2
4.2 plus
50
Minus 1
minus
times negative 0.5.
yeah.
times negative 0.5.
How do we get 50?
50 is the nth term. T equals 4.2 plus 49 times
0.5.
Negative 0.5.
negative 0.5.
Yeah.
Negative 24.5.
T equals 4.2 plus
Negative 22.
negative 24.5.
So T equals negative 20.3.
T equals negative 20.3.
Yay.
Yeah.
All right, good job. Okay. Whoops. There it is.
Who's on the book?
No.